Our first speaker for today will be Owen, who will be giving us a talk on Rust for the Python dev. Over to you.
Cool. Thank you very much. Cheers. Thank you, everyone. I guess I'll give you a very super quick background on myself. I had a bit of a academic bioinformatics natural language background before heading towards Python. For quite a while I was into kind of games technology and serious games development at simulator companies before trying to pivot more towards that data sciencey and Python tech stack. So I used to do a lot of C++, which is where I heard about Rust, and it sounded awesome because it spoke to all the pain points and pitfalls that I experienced as a C++ developer. But yeah, the irony is I looked at Rust first before I ever did anything serious in Python. But since that time, Python, yeah, I've loved Python, haven't looked so much at Rust, keep making false start attempts to try and learn more of it. And this is my latest attempt at pushing myself to do some more in it. So yeah, I still consider myself quite a newbie at Rust, but hopefully you'll get something from this anyway. I should acknowledge that this Rust for the Python developer is a very, very, very well-covered topic. As you'll see, there are many other PyCon presentations about this and PyData presentations about this and other presentations about this. So I guess the good news for you is if you don't like my version of this talk, you've got lots of other choices to go with. And the challenge for me is to try and figure out how to come up with some sort of new spin or angle on this topic. Just touching, I haven't even watched all of these myself. Samuel Colvin, I'm a big fan of Fast API and Pydantic, by the way. His talk is great if you're into the kind of the trade-offs of working in Rust and what you lose in development time, but what you gain in kind of runtime performance. And that's something I'll touch on a little bit, but he probably does it much better than me. And the talk down the bottom by David Holter is great if he's definitely done a whole lot more Rust coding than me, and he can speak a lot more to getting into the weeds of kind of lifetimes and ownership sort of syntax and semantics of Rust. So if you're interested in getting more into the weeds of it, check out that talk. It's pretty good, and I'm sure the others are really good too. I've watched a few of them to different degrees. I will say, even if you've never downloaded the Rust compiler and touched anything with it, chances are you're using something made with Rust, or you're using some tools made with Rust, or you're using some Python packages that are actually Rust under the hood. So there's a few of kind of the better known examples that I've listed up here. So there's Rough, which is like it's both a linter and a code formatter. And it's a really cool project. It goes really fast, partly because it's written in Rust, and partly because it only has to do the parsing of your Python code the once, as opposed to running lots of tools like Black and isort and PyDocStyle and Flake8 and all those. So it's really neat. Yeah, as I said, I referred to Samuel Colvin's talk. So there's the Pydantic, or specifically Pydantic v2 core, which is now written in Rust. Tokenizers, I used to do natural language processing. I haven't done anything much in it lately, but apparently tokenizers package on the Hugging Face uses Rust. There's Polars, which is kind of an alternative to Pandas. It's data frame package. It supports really huge kind of out of core memory, so you can work with tabular data that's much bigger than can fit in the RAM on your computer, and it does a whole bunch of cool tricks. And I guess because it's newer, it has kind of a nicer, cleaner interface than Pandas, which has accumulated a lot of stuff over how long it's lived for. Cryptography package, that was one of the other talks on the previous slide. I haven't worked with that much, but apparently it's one of the most downloaded packages on PyPI, and it's now partly implemented in Rust. ORJSON is a fast JSON serializer, I believe. Data Fusion is like a SQL query engine for Parquet and a lot of those structured file types, and I believe it works with the Arrow memory models under the hood. And I didn't have it before, but as of yesterday's talk, I had to put Robin up there as well, which is kind of your HTTP server backend with Python front end, Rust on the back, and many, many more. So I guess a very quick history of Rust. You probably see it gets quite a lot of good press. And the one thing that gets cited quite often is that it's the most loved, or I guess recently rebranded, most admired programming language by its own developers. So I guess Rust developers like Rust better than most other developers like their coding languages, which is kind of a good sign, I guess. Rust is probably older than what you think it is. I know there's probably hard to decide where to draw the line, where it starts, but I know it started development at Mozilla, and some of the earliest versions of it, I believe, date all the way back to 2006. So it's new-ish, but not new. I think doing the math as of today, it's about half the age of Python. I mentioned it became a whole lot better known and popular sometime around its 1.0 release, which happened in 2015. Indeed, that's when I started hearing about it later that year. I don't know the full history at this point, but at some point, 2021, the Rust Foundation was started, so I give it became less of a Mozilla-specific language, and it became adopted by a lot of the other larger tech companies. And I should have chosen a better acronym, sorry, because I know Microsoft uses it as well, not just the FANG ones. Cool, so I thought I'd do a very quick compare and contrast. I had a bit of a random question first, if you could do me a show of hands. Any of you familiar with the StarCraft computer game or the StarCraft universe? A fair few of you. I changed this slide. In my original version, I thought it would be funny to do a parody of StarCraft. I was going to have Python being the Zerg of programming languages, and Rust was more like the Protoss, because Python kind of spreads everywhere and it evolves really quickly, and Rust is kind of elegant and advanced, but a bit kind of very strict and regimented and stuff. And that kind of idea of a programming language of perfect essence in perfect form seemed to kind of fit the Python Rust analogy, but I was worried too many of you wouldn't get the references, so I just went with a boring Venn diagram instead. Apologies. But I guess I'll walk down kind of the sides of it. Probably if you have some familiarity with CPython, and I'm just going to talk about vanilla CPython, not all the other more exotic flavors. And probably a lot of you are familiar with this to some extent. But I said, so CPython, it's compiles to high-level bytecodes, which are then interpreted, whereas Rust is a low-level virtual machine compiled language. It compiles to native binaries on the platform that you're on. I'm actually curious to hear afterwards. I've never really understood LLVM tech, because VM, I always assumed, implies that you compile to bytecodes and not actual machine code. So if someone can explain that to me afterwards, I'd be curious to learn more how that works. Python, the reason I love it, and I think lots of other people love it, is it's quite well optimized for learning. It's a very easy language to pick up. It's very expressive. It's high level. Rust kind of aims are more about performance and safety, both safety in the concurrency sense, safety in the memory access sense, and that was a bunch of the things that bit me as a C++ developer. I once spent probably over 2 days tracking down a bug that just happened to be an uninitialized variable and trying to follow that code, and the intermittent errors that caused as it bounced across the TLL boundary was a nightmare. And I'm sure, I've been out of the C++ game for a while, I'm sure there's much better static analyzing tools these days that would pick up that sort of thing. But yeah, that definitely bit me, and a bunch of other errors that happened at runtime. I guess Python is very diverse, and it has, in some ways, a lot of self-competition. So there's competing interpreters, there's competing ways to install the same interpreter, there's competing packaging formats, there's kind of competing deployment tooling and stories. One thing, and that kind of takes up a lot of debate in Oxygen. One thing that's kind of nice when you go to Rust is that everything is consistent. Again, there's only one way to download it, one way to install it, one way to deploy it, one linter. Depending on that trade-off, you might like that it takes away a lot of the choices. And I guess that they've definitely learned from Python and that along the way. I guess one thing that's kind of, I guess, technology specific is that Python is obviously a garbage collected language. And I guess if you're new to Python, you might not even be aware of a thing that is a garbage collector that cleans up all your variables over time and returns that to the operating system. And that probably means the garbage collector is doing its job well. Rust, on the other hand, is more like kind of C and C++, in that you manually manage the memory. You allocate it, you deallocate it. I guess the difference being in Rust is it has a very, very clever compiler, and it tries to take away a lot of the kind of mistakes that you can make in C and C++ when you do this thing. And I guess there is some, despite them being technically very, very different languages, there is some commonality to them both. They both have very kind of active and cool communities. They both have a large ecosystem of packages across many different problem domains. They do share some abstractions and syntax. I will talk a little more to that later, and they do have C-type support, so Rust and Python do play quite nicely together. On that topic of Rust and Python playing nicely together, I guess I'll speak to, there's quite a variety of ways to make them interoperate with each other. Probably the most popular ones that I will speak to briefly are the PyO3 crate and the Maturin tool. So PyO3 is giving you, I believe it's Python bindings for your Rust, and probably the most typical use case is when you want to call a Rust function from your Python code, and you want to leverage some of that performance that Rust can give you. That would be the typical use case. Can actually work the other way around as well, that you can embed a Python interpreter or runtime into a Rust application. That's not such a common use case. I guess based on my own background in games technology, I have seen such use case or similar use cases, and typically in games technology we want to write the game engine, the physics simulation, the graphics, and we want that to be all very highly performant code because it has to keep updating and refreshing consistently, 60 hertz a second. You only have a few milliseconds to finish drawing the next frame to show. But some elements of the game, like the game mechanics and the non-player character kind of interaction, and that you might want designers to work with a higher level, more easier to work with scripting language, which could have been Lua and it could have been Python. So that's more a use case where you might want to have Python embedded in something that's predominantly a Rust application. Maturin, you can check it out. This is probably the most recommended tool for building, say, Python wheels, or at least setting up the structure of Python wheels that you can use with Rust functions. Maturin is a command line tool. It's pip installable, or I guess you probably want to pip-x install Maturin in this way. And it has, I won't go into much more detail than that, but it has really great tutorials and documentations. You can try it out. It's very fast to kind of set up a skeleton wheel/Rust project that you can then build and start trying out the integrations. And I've only experimented with it a little, but that's probably one of the ways I've heard recommended as the best way to get started into Rust if you are a Python developer. There are a few other options. Well, I said there's lots of other options. There's a couple of other options I'm going to list here that give you kind of less boilerplate, even arguably quicker/dirtier ways to integrate Rust and Python with each other. So there's the rustimport tool, which lets you almost, as I've seen it work, you can import functions from Rust source files almost like it was just a Python module and use it. And under the hood, it is using PyO3. And you can read about that one more on Itima's blog. That one looks really interesting. I believe it doesn't currently support Windows, so you're on your POSIX operating systems, your Mac or your Linux OS for that last time I checked. And vice versa, if you want to run snippets of Python inside your Rust program, you can check out inline-python. It's a Rust crate you can download, and it gives you a macro that you can put in Python code and still access some of the Rust variables from in there. And you can get more information on that checking out Mara's blog. Mara does a lot of kind of great materials for the Rust community. As I said, the languages are very different, but occasionally in some places, in some contexts, they can look very, very similar. So you have your fairly common symbols and syntax for conditionals, fairly common math operators, and the Rust type annotations and the Python type hints use almost exactly the same colon and dash greater than sort of arrow symbols. So I did a very quick example of a very inefficient factorial recursive function, and you can see the Rust version up the top and the Python version underneath, and almost line for line they are the same in this case. I guess one interesting thing to note, in the Rust version, whatever the last expression is in the function is implicitly returned. You don't need to have an explicit return on that in that case, but otherwise all the same. Just I mentioned, yeah, so Rust also has that sort of async, await keywords, pattern matching. They both implement structural pattern matching. Rust had that earlier. I believe, like many modern programming languages, they steal ideas of other programming languages. So there's many instances of both Rust and Python stealing the same idea from other programming languages. In the case of async and await and structural pattern matching, some of the semantics and ideas are the same, but it plays out a little differently between Rust and Python, although I won't go into those details. There are some very different concepts or abstractions and ideas that are very, very unique to Rust that don't have a parallel in Python, so I will touch on these briefly. Rust has a concept of a borrow checker. As I said, it's all about sort of memory safety. You can have multiple read-only references to one object, but you can only have one mutable reference to that object, and that mutable reference can be passed around from one place to another. And it has a very, very smart compiler that will enforce this, and this is one of the advantages. One of the cool things about Rust is, yeah, that it does have this very smart compiler. It does have really nice error messages that will make it explicit. So I'll get to that example in a moment. What else? So Rust doesn't have classes at all. It does have structs, so a bit like a data class in Python, and you can have functions associated with those structs, although they are typically defined outside the struct definition and they just refer back to it. There's no inheritance in Rust. It does have this concept of things called traits, which are kind of like an interface or an abstract base class where you can say that these structs will implement these particular interfaces or methods, kind of. And there's no exceptions. So definitely Python is a very exception-heavy language, and it uses them for all sorts of things. Rust doesn't have that concept. It does have a way of kind of bundling up errors with the returns from its functions and passing them through. And I guess the nice thing is it can either force the caller to deal with those exceptions. Like if something can potentially return the equivalent of a null value, you can say the caller must have a conditional to handle it being returned as a null or some other error. And yeah, that's pretty much it. I guess I did a quick summary showing Rust, I guess, kind of like C++. It has the curly braces. Variables get scoped to those curly braces. In this example, it's showing me an error because I'm trying to refer to a variable inside a scope that, or it has gone potentially out of scope. And that's probably what this borrow checker is checking. I guess one of the downsides of Rust compared to, say, other eagerly compiled languages like your C and C++ and Go is very smart compiler, and it will try and take away a lot of the foot guns. But because it's smart and it does lots of checks, it tends to compile quite slowly. I believe that story has improved. It's not as bad as it was in the early days when I first discovered it, but it still is a common criticism of the language that it compiles quite slowly relative to some of the less safe languages. I guess, yeah, a little bit of talk about the garbage collector. So system in Python that manages cleaning up your variables once they're no longer referenced. And that, I said, I originally came from a games tech background, and we were very much C++. We can manage our own memory, and they did, especially if you look at sort of domains like console game development. Some of those developers are are wizards and they do crazy sort of memory allocation. I don't know if you ever look at the CPython internals and that, and things like Arena and how Python manages like pre-allocating chunks of memory and that, but the console game development, they kind of take that up to level 11, where they like pre-allocate all the memory and have their own abstractions for managing it and not doing any sort of allocations or deallocations on the fly. So yeah, garbage collected languages like CPython and Java, it's kind of great that it frees you up from having to think or worry about the garbage, about this manual memory management. But I guess the reason that it wasn't used a lot in games tech is when the garbage collector does finally run, it can give you kind of unexpected runtime performance or pauses, and that's what they were really trying to avoid in the games, where you want to keep that consistent frame rate and you don't want any unexpected stops. So I guess the different trade-off that Rust gives you is it takes away the garbage collector, you have to manage your own memory again, but it's also going to try really hard not to let you make any mistakes with that memory management. You shouldn't get dangling pointers anymore. You shouldn't get multiple threads trying to update the same chunk of memory at the same time, and the race conditions that can cause. So yeah, I experienced that a lot as a C++ developer. So it makes memory management safer, not necessarily easy though. You have to be more conscious of the lifetimes. Indeed, a lot of Rust is about that sort of lifetime management of variables. And I know another, I guess, common issue or complaint is a lot of people end up fighting the Rust compiler, trying to figure out the right sort of lifetime syntax and annotations to use on their variables to make it happy. But so if it compiles, it's probably going to work, but you might have a very hard time getting your code to compile until you have a very good grip on this concept of lifetime and ownership. I guess one thing, I'm a big Jupyter fan in the Python world, and I love breaking out Jupyter and doing just some quick hacky interactive coding when I'm prototyping or learning new libraries and that. And usually one downside of working with these eagerly compiled languages like C, C++, and that is that you lose that kind of very interactive REPL or Jupyter experience of just hacking, running a single line, looking at the output, and iterating fast. But I did discover this evaluation context for Rust, which both gives you a REPL that you can use with to interactively write and execute single lines of Rust. It also offers you a Jupyter Lab kernel that you can install, which have shown up here, and you can use it in a similar way. And this is, yeah, I think it looks really cool. This is one of the main things I was looking for, and I think one of the main helpers when you're starting out in a language is it's so much nicer and easier to learn concepts when you can just try small code snippets at a time and get the really instant or near instant feedback on how it runs and stuff. So I definitely recommend checking out this project if you're getting started in Rust and you're trying to experiment and learn new concepts. I don't pretend to understand what sort of magic it does to let you run single lines, whether it's actually compiling it under the, well, I assume it is, but I don't pretend to know it, but it's cool that it exists. Another project that's kind of interesting is that there are many versions of the Python interpreter. One of them that is quite popular, well, not CPython popular, but still relatively active as a repo and interesting, is the RustPython. And they've actually they appear to have done a really good job there. Like, they're keeping up with the Python versions. So they do have an implementation of Python 3.11.4 last time I checked. I did listen to some interviews of the guys that started this. And I think they were looking for a project to just get into and start learning Rust. And it blows my mind that someone would pick re-implementing the Python interpreter as a starter project for learning a new language. But yeah, super impressive that they've done it, and that, yeah, you can go try that out. It's still, after all, it's been out for many years now, I think. They still say it's not ready for production use, but it's an active repo, and they do keep updating it and fixing bugs. And yeah, it's super impressive. And I doubt it ever will be a contender for a new reference implementation of Python, but I like the idea that there might be a serious challenger for CPython one day. Cool. And I thought for most of the remainder of the talk, I would just do a bit of a mini awesome list of crates in the Rust ecosystem and spread over a few different domains. My interests are fairly wide. Once again, this is broad and very, very shallow. I don't pretend to have used a lot of these crates, but I do spend an awful lot of time just trawling through GitHub, looking at what repos are popular in both the Python and the Rust side. So I thought I'd pick out some ones that do seem popular and interesting and speak to them a little bit. So if you are interested in getting into Rust, hopefully some of these packet crates on the different slides that I'll show you might take your interest and you'll want to play with them some more. I won't talk to all of these ones on backend web development. Rust has a very rich ecosystem of kind of like HTTP servers that you can check out, and they are some of the most performant ones that you can use. But I guess I'll speak very quickly to a few. So the Rocket one, that looked interesting to me because I recognized, I said I'm a big fan of fast API, and I did notice quite a lot of fast API style syntax, functions for REST endpoints, arguments to those functions mapped to the parameters for those endpoints, and it would do type checking, fast API style, based on the types of parameters those endpoint functions had and what arguments they would actually accept. Skip over the next ones fairly quickly, but there's Hyper, which is a popular low-level HTTP client and server, and a couple of crates built on top of that, Axum and Warp. ActiveX Web is both HTTP and streaming web framework, and I know it has a lot of integrations with other popular Rust crates. And this last one, Leptos, looked kind of interesting to me. It reminded me of the Anvil platform, if anyone's tried that on Python, which is kind of and Anvil was end-to-end Python, front end to the back end. You had Python functions on the front end side, and it's almost like you were remote procedure calling functions on the back end. So it almost abstracted away the distinction between what was client code and what was server code. And this Leptos looks like something similar in that vein, but for Rust. So I thought, and all of these are at least GitHub popular type repos, so that looks cool. Quickly more on the front end side, so there's request. Don't know how to say it, but it's like the Rust equivalent for the request library. It does handle asynchronous requests, so I guess technically it's maybe more like HTTPX, but that looks cool if you want to try it out. There's the U framework, which is all about Rust running on the front end. I guess I didn't really speak to it, but Rust supported WebAssembly quite early on, and you can compile to WebAssembly targets and run your Rust apps client-side in the browser. So yeah, that U looks interesting if you actually wanted to do more of the UI work and the front-end work purely in Rust. And yeah, it has, for those of you that have worked in React before, it has the JSX-like templates. ORMs and database access, so a couple of popular crates in this space are Diesel. I'm not that familiar with it, but yeah, supports Postgres, MySQL, and SQLite. And there's SQLX, which is like a query builder. I think it supports almost all the popular relational DBMSs. Apparently it does compile time validation, I think, against the database schema. So that's kind of interesting if you want to check out more of the database and database access side. This is more my thing. I came into Python more from the data science-y Conda side, so this is more my bread and butter, and it's interesting. I already mentioned Polars, which is like an alternative to Pandas, but it is more tightly focused just on data frame operations, whereas Pandas gives you a lot of extra stuff like data visualization and that as well. But Polars, it interacts with Pandas, so you can quickly convert a Pandas data frame to a Polars data frame, vice versa. It's much faster, like it'll use all your hardware much more effectively than Pandas. I guess that's a common criticism of Pandas, that it's single-threaded. And yeah, and it's out of core too, which is really neat that it does a lot of kind of lazy operations and generates them only as it needs to. So, and it'll load data from your disk as it needs to. So you can work with data that's bigger than the RAM on the machine that you're working on. ND array seems to be like the closest parallel to NumPy in Python. So it's your linear algebra matrix library. I believe this might actually be a few related crates on the Rust side that give you different parts of that ecosystem. in terms of a parallel for scikit-learn, there's Linfa. I guess there is a growing kind of data science, machine learning sort of community and ecosystem happening on Rust, but it's definitely not as mature as Python's and not as big. But Linfa is, yeah, I think it even documents itself as being scikit-learn inspired, so it will give you a lot of the basic ML models and ways to fit them and use them. For more of the deeper learning, sort of PyTorch/TensorFlow style stuff, there's this burn package. And I'm still trying to understand its level of abstraction because it actually can hook into ND. It can use different linear algebra libraries under the hood, so it can use ND array or it can use PyTorch, and there's a few others I think it can hook into underneath. That's your thing. There's Lance, which is a columnar store format, kind of like Parquet, and supposedly, according to their marketing materials, it's even more performant than Parquet. And lastly, Data Fusion, which I believe I mentioned in one of the earlier slides too. This is like a SQL query engine that works with arrow types, so you can use it against Parquet files, CSV files, and the like for your kind of structured tabular data. I also mentioned that I was really into games technology, even though I've been out of that space for a long time. But here's a few of the popular game engines in the Rust ecosystem. Probably the most well-known from what I can see is this Bevy one. It's a fully cross-platform game engine, so you can compile it and run it on each of your major sort of Linux, OS X, Windows, and also it can work, WebAssembly, so you can do client-side games running in the browser. It seems to have one of the largest community and arguably maybe one of the best documentations. And also Fireworks is very similar. It can go across those same platforms as well. I believe Fireworks just has slightly smaller community, slightly different abstractions to how the game engine is architectured. So if you were to pick between them, you probably just want to look at both and see which one fits your brain a bit better. Nano is like a lot of games and in technology, but it's more focused on real-time multimedia. So your visualizations and sound and stuff, unlike a game engine, is not going to be about gamepad controllers or anything, or physics engines like the above two have options for. And the last one is Piston, which is a looser collection from what I can see. It's still quite popular as a code repo, but I don't know its relative popular. It doesn't seem quite as popular as the above options like Bevy and Fireworks. And I guess I got to some of the foundational crates in Rust. There's probably a heap more. I'm still learning as well. But you'll see this, I hope it's pronounced CERD, serializer, deserializer. This is like, you can do your JSON serialization, deserialization, but it actually supports dozens and dozens of different formats that you can serialize Rust structures to and deserialize them from. And Tok.io is that's used by, it seems to be half the crates in the Rust ecosystem, and that's all about doing asynchronous run. So almost.
We are a little over time, so we're going to have a big
sorry. Thank you.
Unfortunately, we won't have time for questions, but thank you, Owen.
Cool. Thank you very much. Sorry for missing my cue.